Topic 4.5 Logarithm. A logarithm is a mirror image of an index. If x equals a power n, then log x to the base a equal to n. The students may read the mathematics expression as the log of x to base a equal n. Okay, another example, here we have 1000 equal 10 power 3, which 3 equal log 1000 base 10. This can be summarized into this statement. First, we have this index statement, and second, we have the log statement. The index statement, if we have x equal a power n, this is very similar to the log statement. Log of x to base a equal to n. From x equal a power n, we can change it into log a log base a x equal log base a power n. Log a is equal to 1. So we are left with log e x equal n. Let's do question from example 5. Starting from example 5b, here we have 7 power 3 equal 3, 4, 3. We want to convert the following into logarithm form. Okay. Let's change this into log base 7. 7 power 3 equal log 7, 3, 4, 3. Log 7 is equal to 1. Later on, we get 3 equal log base 7. 3, 4, 3. Next question, C. Here we have 7 power p equal q. So we change it into log base 7. 7 power p equal log base 7 q. So again, log 7 base 7 is equal to 1. So on the left, we are left with p equal log q to the base of 7. For question B, we have 3 power negative 3 equal 1 over 27. So for this one, log 3, log to the base 3 for 3 power negative 3 equal log to the base 3, 1 over 27. So again, log 3 to the base 3 is equal to 1. So here we have negative 3 equal log 1 over 27 to the base 3. Question E. P power negative 8 equal 7 over 45. So we change t power negative 8 into log to the base of t power negative 8 equal log to the base t 7 over 45. So log t to the base t equal to 1. So we are left with negative 8 equal log base t 7 over 45. Let's continue to the next question. This time we want to convert the following to index form. Question B, we have log base 7 square root 7 equal 1 over 2. Okay, because we have log base 7 on the left, we will add log base 7 on the right as well. And then add 7 power 1 over 2. Why we add log 7 to the base of 7? Because we know that this is equal to 1. So, it's just that we multiplied 1 over 2 by 1, which still equal to 1 over 2. Okay. And then we can cancel out log 7. So on the left, we are left with square root 7. And on the right, we have 7 power 1 over 2. So the original statement is in log statement. And then we change it into the index statement. Let's proceed to the next one. C. This time we have log base 3 1 over 9 equal negative 2. So on the left we have log base 3. So on the right we will add log 3 base 3 power 2. Because log 3 base 3 is equal to 1. And then just copy on the left. Next, we will cancel out log 3. So we get 1 over 9 equal 3 power negative 2. 3 power negative 2 is 1 over 3 square, which equal to 1 over 9. So on the left we have 1 over 9, on the right also we have 1 over 9, which makes our answer correct. D. Now we have log to the base of 6, 1 over 6 equal negative 1. So let's change negative 1 into log statement first. So log base 6, 6 power negative 1. Okay. And then we cancel log 6 on both sides. So we are left with 1 over 6 equals 6 power negative 1. This is the answer in the index statement. But to check, we can change 6 power negative 1 into 1 over 6. So we get the same answer on both sides, left and right. So let's discuss one more. E. Log base 27, 3 equal 1 over 3. So let's change 1 over 3 into log statement. Log base 27, 27 power 1 over 3. We can cancel out log base 27, so we get 3 equal 27 power 1 over 3. This is the answer in index form. Okay, to check, we can continue. 27 power 1 over 3 is the cube root of 27. Punca kuasa 3. 27 punca kuasa 3 is equal to 3. So we get the correct answer on both sides. Rules of logarithm. A logarithm obeys several rules. Below is the list of the rules. Okay, rule number 1. If we have log base e xy, this is equal to log base e x plus log base e y. Rule number 2. If we have log to the base e x over y, this will equal to log to the base e x minus log to the base e y. And then rule number 3, when we have log to the base e x to the power of n, we can bring the power to the front. Then we get n log base e x. So these are the 3 rules of logarithm. So again, when we have log at the front of x multiplied by y, we can separate with addition sign. And when we have x divided by y with a log at the front, we can separate them by adding a minus sign. And then again, when we have log base e x power n, we can bring the power to the front. Special cases of logarithm. Below is the list of some special cases in logarithm. Okay, here we have 4 special cases of logarithm. Special case number 1. Log base e 1 will always equal to 0. Again, log base e 1 will always equal to 0. Special case number 2. Log base e equal to 1. We have discussed this in the example before. Then special case number 3. Log base e x is not defined if x is less than 0. So x must be positive. Special case number 4. Log base e0 is also not defined. Okay, again, x here must be positive and x cannot equal to 0. Let's discuss some examples. Example 6. B. We have log 6 plus log y. We want to simplify this statement to a single logarithm term by using rule 1. Let's look at rule 1. Rule 1. When we have log base e xy, it will equal to log base e x plus log base e y. So when we have log 6 plus log y, this will equal to log 6y. 6 multiplied by y. C. This time we have log base 2 3xy plus log base 2 xy squared. Okay. When we apply rule 1, we can take log base 2 and then 3xy multiplied by xy squared. And then we can simplify 3. So x multiplied by x, we get x squared. Y multiplied by y squared, we get y cubed. So the answer is log base 2 3x square y cube. Question D. This time we have log 6x plus log 5z equal log and then 6x multiplied by 5z. Log 6 multiplied by 5 is 30. And then x multiplied by z. X, z. Question E. This time we have log distant 7y plus log distant y power negative 7. So by using rule 1, we can take log 10 and then 7y multiplied by y power negative 7. Log 10, 7. Y multiplied by y power negative 7 is y power negative 6. So we can also write it down as log distant 7 over y power 6. And then one more question, F. This time we have log base 5, 15 plus log base 5b. So to simplify this into a single logarithm term, we can take log 5 and then 15 multiplied by b, which equal to log base 5, 15b. So now we will try some question where we will apply rule number 2. Okay, let's look at rule number 2. When we have log base e x over y equal log base e x minus log base e y. The first question is when we have log base 3 24 minus log base 3 6 equal log base 3 24 divided by 6. 24 divided by 6 can be simplified into 4. So the final answer is log base 3 4. Question D. Now we have log base x 8y power 3 minus log base x 2y. So by using rule number 2, this will equal to log base x 8y cubed over 2y. Let's simplify. Log base x 8 divided by 2 4 y cubed over y squared. So the answer is log base x 4y squared. Now we have log base t 2h power negative 3 minus log base t 5 equal log base t 2h power negative 3 over 5 equal log see 2 over 5 h power negative 3. And the last one, log this 10 400 minus log this 10 50 equal log this 10 400 over 50. So we can simplify 400 divided by 50. We get log base 10 8. And that is the final answer. Okay, this time we will try some question which we have to apply rule 3, where log base a x power n, we can bring the power to the front. This question is from question number 3b. X log base 10 5. This is equal to log base 10 5 power x. And then if we have 3y log base 10 5, so we can bring 3y and then we get log base 10 5 power 3y. Okay. Let's solve some of the other questions where it involves special cases. For example, log base a1 equal to 0, log base aa equal to 1, log base ax x must be positive, and log base a0 is not defined. What is the answer for log 10? This one, we can change it into log base 10 10. Log base 10 10 is equal to 1. Log base 7 0. This is undefined because x cannot equal to 0. What if we have log base 3 negative 27? How can we solve this? This is also undefined because x must be positive. Let's say we have log base a x. So x must be more than 0 and x cannot equal to 0. Log base 10 1 is equal to 0. And lastly, log base 2 2. Log base 2 2 is equal to 1. And that is all for today's class. We will continue with the other examples tomorrow. Thank you.